If you know anyone who was not able to make it today, there is a recording available. So welcome to our webinar this afternoon. We are going to do a deep dive into using data to teach Algebra 1. Before we get started, I'd like to introduce myself. My name is Colleen. I am a math education specialist with Tuba. And prior to working with Tuba, I was a classroom teacher for 7 years. I taught 8th grade math, Algebra 1, and geometry. So Algebra 1 is definitely very near and dear to my heart. And I also spent 3 years working as a new teacher coach in high needs schools, actually on the island of Oahu. So I've also been in a number of math classrooms outside of my own. And so really excited to talk to you all today about how we can use data and the Tuba tools to enhance the Algebra 1 curriculum. So before we get started, I want to share a little bit about our vision at Tuba and really why we exist as a company. And our vision is that students will and can enjoy learning math and science when it is grounded in real world application and they're able to see the connections between their lives and what they're learning in math class. And so as we go throughout our webinar today, my goal for this webinar is really that I'm able to demonstrate some ways that we can make those real world connections between the algebra content and real world data sets and bring those real world experiences into the Algebra 1 classroom in particular. And I should say that we're going to focus specifically today on Algebra 1 because we wanted to do something really specific, but data and data science, data literacy are things that can be brought into any content area. And so I will take a moment later on to show you some other ways you can incorporate data into your classroom, whether you are an Algebra 1 teacher or not. I know there's some people on this call may not be Algebra 1 teachers. So I'll talk briefly about how we can use data in different content areas or different courses as well. So I want to start off with what we believe is kind of a problem in math instruction right now. And I say this as someone who just recently left the classroom this past summer, that math instruction today relies really heavily on procedure and repetition. And that is not inherently bad. There is a lot of value in procedure and repetition when it comes to, in particular, math learning. So there is tons of research to say that students need to see a concept multiple times in order to be able to understand it. So nothing inherently wrong with that. However, because that is often the emphasis, what gets left out is the real world context that undergirds all of our mathematical concepts that we teach in our math classroom. And in our case today, specifically the Algebra 1 classroom. And our hypothesis at Tuba, and we believe that this is borne out in the research, is that this lack of real world context leads to a lack of student engagement. And we can see the negative impacts of lack of student engagement in student test scores, in sort of national aggregate data on student performance. And so our goal at Tuba and our goal in this webinar is to really think about the ways we can bring that real world context into the Algebra 1 curriculum. I just want to share 2 quick quotes that I found in some research that really spoke to me about the need for real world context when it comes to math learning in particular. So I'll let you read this one. It's a little bit lengthy. There is the source for this quote on the QR code at the bottom if you're interested in reading more. So what really stood out to me about this quote is the idea that students are interested in all of the ways that math exists in the world around us, and conversely are very uninterested when they aren't able to see those connections to the world around us. Having just recently left the classroom, as I said, I feel that Gen Z in particular is incredibly interested in understanding the why or where this is applicable to their lives. And so bridging that gap or helping students to see the bridge with that gap is incredibly useful. And I think in particular with this generation. I'll leave you with one more quote. This one's a little bit shorter. And the source for this is also at the bottom. This actually comes from some authors who did research on improving math instruction for English language learners, another subject near and dear to my heart since the majority of my students were English language learners while they were also learning Algebra 1. And so just the idea that making those real world connections for our EL students in mathematics is incredibly important, not just for their attainment or their achievement in math, but also their enjoyment of it, like their actual enjoyment of the content area and the subject. So a little bit of the framing of why we're here, right? To bring that real world connection into the classroom. So I wanted to share a little bit about how we do that at Tuba before we get into some actual examples of how we're going to do this in the Algebra 1 curriculum. So Tuba, in case you're not aware, is a supplemental instructional program that combines data visualization and analytics tools with research-based pedagogy and really pedagogically sound lessons and supplemental curricula. And our goal in combining these two is to be able to empower students to work with raw data and then take that raw data that they've worked with and be able to make decisions and be able to represent and talk about that data in context. And I could go on to a whole tangent, which I won't for the sake of time, about why data and data science in particular is so important for this generation of students. But just to put it briefly, we know that data literacy is going to be a critical 21st century skill for our students. We know that access to higher paying jobs is going to require that students master these data literacy skills. And so at Tuba, we are hoping to use these tools that we've created and the curriculum that we've created or the lessons that we've created in order to get students to develop those really critical skills. And our goal specifically in math is to address some of those concerns of the classroom that relies heavily on procedure and repetition and lacks that real world context. So our goal is to provide math instruction that's grounded in the real world. We start with real world data sets. We don't like fabricate that real world connection. Our connection is very clear from the beginning because we're always beginning with real world data. Our lessons are then designed from those real world data sets to enhance conceptual understandings of data and data literacy, but also of other concepts that might be traditionally hard for students in the math classroom. So I'm thinking specifically about topics like fractions or proportional reasoning or modeling, things that start to become a little bit more abstract in math. We try to make more concrete by really linking it to the real world. And I also want to add that all of the choices that we make onto our Tuba platform are research based. So all of our tools are really heavily backed by research. They're also super user friendly and student centered, which you'll see when we start to get into some demonstrations of how we can use Tuba for Algebra 1. Last bit of my spiel before we dive into the Algebra 1 content, a little bit about what exists on our Tuba platform. So today I'm going to be highlighting for you two main things. One is our activities, and these are opportunities for students to really dig into a data set and explore some real world phenomena, either in math or in science. Obviously, we're going to be focusing on math. These are pre-developed activities and lessons from our content specialists that are all based on real world data sets. And then the second thing that we'll explore today is data stories. And those are sort of quick activators that teachers can use in the classroom to help students to build some of those data literacy skills. So being able to read a graph, interpret it, and then draw some kind of conclusion. And so those are the two things we'll be exploring today. You've heard me mention data sets multiple times. We do have a full library of data sets that have been curated from primary sources like NASA and NOAA or the National Institutes of Health or the Weather Service. So we have all these really great real world data sets that exist in our data set library. I will show that to you briefly, but we really won't spend too much time on that. If you're already a Tuba user, you probably noticed that we've rolled out our data sets into their own dedicated library. So definitely take some time to dig into that separate from this workshop. And finally, Tuba is not a graphing calculator. I want to always like to make this distinction, especially for math teachers. I am a huge proponent of Desmos. I use Desmos all the time in my classroom. However, this is not Desmos. We're not aiming to graph just a static set of data points or a single equation. We're really trying to explore real world phenomena through a real world data set and actually answer some questions and make some good conclusions based on that data. So we are not a graphing calculator. Okay. On your screen, you're going to see a few curricula that are that I've highlighted here. And the purpose of showing you these curricula is it's not, like an endorsement or anything like that. It's just to say that whether you use one of the curricula that we have pictured here or you use a separate curricula, our hope is that, or my hope is that I'm able to show you some ways that you can fit these this use of data into your curriculum, regardless of what you use. Okay, so I have highlighted here a few that I know some people who registered for this webinar use. So that includes the Big Ideas Algebra 1 curriculum, the Illustrative Math Algebra 1 curriculum, Springboard, and the Open Up Math Algebra 1 curriculum. So I know that these are some curricula that get used by many of our users. Again, the goal is that I'm showing you ways that Tuba can sort of align with different curricula in the hopes that you can hopefully see that alignment with your own curricula as well. I'll also share my contact information again at the end of this session. And if you ever have questions about how Tuba can fit into your specific long-term plan or your curricula, I'm absolutely happy to help you see some of those opportunities as well. So we're going to run through 4 different topic areas where Algebra 1, or where data and the use of data fits really nicely into the Algebra 1 curriculum. I will say this is not an exhaustive list. I chose these 4 because I think they provide really strong uses and really clear use cases for using data in the Algebra 1 curriculum. Obviously, there are others. And again, if you want to dig into some of those others with my help at some point, I'm absolutely happy to do that with you. But we'll start with one variable statistics. I've pulled out one of the sort of overarching standards from the Common Core around one variable statistics. Students are summarizing, representing, and interpreting data on a single count or measurable measurement variable. If you'd like to check out some more Common Core standards that deal with one variable statistics, I have included them in that little QR code on my screen. So I pulled out this lesson from the Big Ideas curriculum. Big Ideas covers one variable statistics in lesson 11. It's pretty common for statistics to be sort of at the end of an Algebra 1 curriculum. So Big Ideas covers this in unit 11. And in this lesson, students are looking at some different data visualizations. In this first example, they're describing the variation of data in this graph, which is looking at the different weights in pounds of players on a football team versus players on a baseball team. And they're describing the data in different ways. And I pulled this out from the heading of the lesson for Big Ideas, which says mathematically proficient students use diagrams and graphs to show relationships between data. They also analyze data to draw conclusions. So this is the goal of what Big Ideas is hoping that students will get out of this lesson. The essential question is, how can you describe the variation of a data set? Okay, so my goal again is to show you how I believe that Tuba can help us to enhance a lesson such as this. I'm going to show you one more example before we do that, though. Illustrative math actually puts data or one variable statistics into the first unit of study for Algebra 1. So this example comes from Unit 1, Lesson 5, where students are looking at measures of center and calculating variability. So very similar to the lesson that we just saw from Big Ideas, where we're looking at variation in the data. In this case, we're trying to develop our interquartile range, looking at how many data points are, in the different parts of the 5-number summary. And then we have two sort of real world examples that go along with that. One is about a pod of dolphins and their various lengths. One is about a vocabulary test and the number of questions. And what you would need to get to go into each of the different quartiles. So both of these lessons are incorporating this idea of like real world context, right? But it's my opinion that we can go a little bit deeper by using a real world data set and with Tuba. So we're going to do a quick little demo of a data set. This data set is on different types of cereal that we might find at a grocery store. And the goal of this lesson in particular is to look at our data, look at the variation in our data, and be able to look at different measures of center and determine which measure of center is going to be the most appropriate to represent this data set. This lesson, whenever we open a lesson on Tuba, is always going to tell us what it's about. We can look at all of the questions that students will get answered as they are working through the assignment, and then any standards or topics that this assignment is linked to in our content library. Okay, so if I am just looking at this data set or looking at these cases, they will appear on our tool completely mixed up in a random assortment on our graphing screen. If I want to learn a little bit more about this data, I can click on the About in the bottom left of our screen and learn a little bit about where this data comes from, what the source of this data was. So the source is actually taken from grocery stores. And then what kind of topics this data set will cover. So I'm going to play around with this data set, and I'm going to start by looking at how this data set or how these data stack up when we organize them by fat content. So here we have all of our, we have all of our different cereals that were observed in the grocery store and how they're organized by fat content. So right away, as soon as I drag this fat content to the x-axis, I can start to have a conversation with my students about how this data is distributed. So we can have a conversation about whether the data is skewed in one direction or the other. And we can also have a conversation about if there appear to be any outliers for this data. Okay, the next thing I want to look at is I want to calculate the mean and the median, since the goal of the two lessons that I showed you, as well as this lesson on our platform, is to look at the different measures of center of our data set. So, and I'm also going to show our labels so we can actually see them. All right, so by doing that, we found that the mean was 1.67 grams, our units are grams, of fat versus 1 gram of fat as our median. So Now that we have this visualization of these two measures of center, we can also now have a conversation about which of these we believe, or start to make some predictions about which of these we believe is a better measure of center to represent this data set. Another thing that both of the lessons that I showed you in those two curriculum sources get at is this concept of outliers. And so we can also, by using this data set, talk about what outliers exist in this data and which serials those are. So let me go ahead and click on this outlier. So this outlier over here has 11 grams of fat. This is Nature's Path peanut butter granola, and it has 11 grams of fat. And I just want to point out something too that is really cool about our Tuba tool, which is that when I click on a data point in the graphing screen, I also see it get represented over here in the case card. So I can actually look at all of the different attributes of this piece of data on the case card. I could also look at it in the table view as well. So it is the 11th case in our table view. Okay. Oh, I'm so sorry. It's our 25th case in the table view. All right. So now that we've been able to maybe identify a potential outlier, we could also probably make the case for additional outliers, but I'm going to focus on this outlier in particular. Then we can actually use our Tuba tool to filter that case out. So rather than having to manually take that data point out of our data set, we can take it out by using our filter tool. And now we can have a conversation about whether our mean or median has changed at all as a result of removing that outlier. So we can have a lot of really rich conversations about the spread or the variation of this data with just a few clicks in our graphing area. And we get to have this conversation in the context of products that our students have likely all encountered when at the grocery store, or at least they have encountered many of them. So you may even be able to have students go in and find their favorite cereal. My genuine favorite cereal is Cheerios. So if I were to look at Cheerios, I could see that they have really not that much fat. They have 2 grams of fat. They're more than the mean and the median. But I could look at all the different attributes of my favorite cereal. So I can really make connections with the content that we're learning and some actual real world application that students might also be interested in. I'm going to reset my plot one time and also show you how we can go from this distribution to a box and dot plot or a box plot with outliers. So you may remember from those 2 examples that I showed you in the curricula, we also want to be able to talk about the 5-number summary. So our tool makes it super easy for students to see that 5-number summary. And we can either see that 5-number summary without all of the data points visible, or we can include them all. And then when we have that question of, how many data points are above or below, we can really easily see that within the context of our 5-number summary. All right, so that is one variable statistics. I'm going to show you one more, and then I will pause just in the event that there are any questions. And then we'll do our final 2 examples as well. So next we have 2 variable statistics. I've pulled 2 Common Core standards that address 2 variable statistics. And if you'd like to see some more associated standards, you can do so by looking at the QR code in the right. But for 2 variable statistics, students are expected to summarize, represent, and interpret data on 2 categorical and quantitative variables. And they're going to represent data on with those quantitative variables on a scatter plot and describe how the variables are related. So this is a standard that you might see covered in an Algebra 1 curriculum. And I have pulled out another illustrative math example where students are asked to look at causal relationships between two categorical variables and describe the strength of those relationships, and then, provide some reasoning. So we have these 4 real world examples here. We have used car price and original sale price, car price and number of cup holders, oil changes, and number of miles that have been driven. So students are presented with a real world example, and then asked to, think about how that applies to this concept that they're learning of causal relationships. Again, I believe with a real world data set, we can take this a step further. So we're going to look at a real world data set around students' SAT scores. And our goal is, again, going to be to talk about the relationship between these two variables. But instead of doing so, with just sort of like a brief real world context, now we're actually going to do this in the context of actual SAT scores that were collected among Brooklyn high schools in 2012. So I'm going to actually pull up a little bit about this data. So these data summarize the 2012 average SAT scores of 32 high schools in Brooklyn. So if you're teaching Algebra 1, your students are either in high school or are approaching high school. And so the SATs are likely on their minds. If they're not on their minds, it's an opportunity for you to bring it to their minds. So we can actually talk about the relationship between two variables that are going to be important to students or matter to students in the near future. So we're going to look at the strength of the relationship between SAT math scores and SAT reading scores. Okay, and I'm going to put this here so you can see all of the different schools that we have collected data from in Brooklyn. All right. So right away, I would ask my students to think about or make a prediction if there is a relationship between these two variables. Likely there is. And once we've plotted this on our graphing screen, then we can see that there is a relationship between our two variables, between math SAT score and reading SAT score. And there seems to be some kind of positive linear association between these two variables. And we could talk about the strength of that relationship, whether it appears to be a strong relationship or not. We could also look at perhaps some outliers and see what if we removed a couple cases from our data set, would that make the strength of the relationship stronger or weaker? So there are lots of conversations that we can have around these this concept of two variable statistics and association, but we're going to do it in the context of this real world data. And the next topic that we're going to talk about is linear modeling. So if we wanted to, we could start to get in. Sorry, thought I had clicked my button. There we go. So if we wanted to, we could start to talk about how, this looks pretty linear. And once we have this, a movable line in here that we can actually manipulate and drag around, we can talk about whether or not this relationship appears to be strong. So lots that we can do here within the context of real world data and relationships between two variables. I'm going to pause there and just check to see if we have any questions that I can answer before we move on to our next two topics. All right, so the next topic that is probably the biggest topic of Algebra 1, or one of the biggest topics of Algebra 1, is linear functions and modeling. And so I've pulled two standards. These are not Common Core standards, although we do work with a lot of teachers from Virginia and Texas. So I wanted to include some standards that were not Common Core. I was also a teacher in Virginia, so I know the Virginia SOLs really well. And so I've included these two standards, what that students are expected to be able to do in Algebra 1. These are two of our really priority standards for Algebra 1 in Virginia. That's to determine the slope of a line when given the equation of a line, the graph of a line, or 2 points on the line, and write the equation of a line when given the graph of the line, 2 points of the line, or the slope. Cool, and a point. And in Texas, students are being asked to graph linear functions on the coordinate plane and identify key features, including the x-intercept, y-intercept, zero, and slope in mathematical and real-world problems. So obviously, students are taught these concepts of slope, but it's important that students are not just, taught the concepts of slope and able to regurgitate what, y, m, x, and b are, but that they really understand what these concepts are in context. And it's our hypothesis that if we give them this context from the beginning, they develop a much more, a deeper conceptual understanding of linear models. So I pulled this from a released Virginia SOL practice test, and students are asked to look at this table, which shows the number of months that different buses in their district were used and the miles driven, and then come up with a line of best fit and use that, not just come up with a line of best fit, but actually use that best fit to make a prediction. So they're really applying this idea of slope, of developing an equation from a set of data and having to use that to make a prediction in a real world example. So although the standard talks about, just slope and being able to write that equation, what students really need to know to be successful is how to use that information in context. And so data, using real world data, really grounds that concept and allows students to get to that application. In Texas, students are asked to do something really similar. So they have a company website that tracks the number of visits and the number of clicks. This is actually super applicable to students' lives. And so they're given this set of data, and based on the line of best fit or based on some kind of linear model to represent this data, they want to be able to make a prediction about the number of clicks on an advertisement if a certain number of people visit the website. So if we want to be able to prepare students for these two types of questions that we know they're going to see on their standardized tests, then we need to be giving them opportunities to model or to work with linear models in real world context. So because this is such a big topic in Algebra 1, I want to give you two examples of how we can use data to really deepen students' understanding of linear modeling. The first is from a data story that we have on our platform. Let me make this a little bit bigger. So in this data story, students are looking at participation and achievement in the Winter Olympics for the United States over time. So they want to look at, how much have we been participating in the Olympics and how well have we been doing? So as I mentioned previously, the goal of data stories are to be these sort of quick activities that teachers can use as activators to get students thinking about data, to get students talking and reasoning with data without the full exploration that we would do on an activity side. So in this data story, students are given 2 lines of best fit. They're asked to talk about what the slope of the line of each of these means in context for US participation in the Winter Olympics. So, or the participation in the Winter Olympics in general, excuse me, sorry. We're going to get to US participation in a moment. So they are looking at each of these slopes and saying, what does this actually mean for the number of countries that are participating in the Olympics over time? And so they'll have to actually do some reasoning and responding using their mathematical language here to be able to describe that. Next, they're looking at the slope of the line of best fit for US performance and how well we've been doing in terms of the number of medals we've been getting over time. Next, we're looking at how the number of gold and silver medals are increasing or decreasing over time. And finally, we need to actually summarize what this means in context and use evidence to support our answer. So this is practicing that skill that they are going to be asked to do on their state test, where they're using evidence to support their data, they're making predictions, and sort of like using that or describing what that means in context. So that's one sort of quick way that students can be working with data when it comes to linear modeling. And then if we want to go even more in depth, we can actually build some models in context with students so that they're able to really understand what their slope, y-intercept mean in the context of a true real world example. In this case, our real world example is a data set on M&Ms. So we're going to be looking at this data set on M&M measurements. We're going to compare the diameter and the mass of different types of M&Ms. We have 816 cases total in this data set, and we actually are going to make that number a little bit smaller. We're going to focus on just one of the types of M&Ms that we have in our data set. So we have 3 different types of M&Ms in our data set. Peanuts, peanut butter, my favorite, and plain. So that's a little bit about our data and how many of each we have. We actually could, if we wanted to, look at just, so we're going to be looking specifically at the diameter and the mass. We could look at this in the context of one variable statistics again, just look at each of these individually and the distribution of for example, the diameter of our different M&Ms. We could talk again about mean, median, and mode and our different one variable statistics that we might be interested in. But we actually are going to compare or look at the relationship between the diameter and the mass of just our peanut M&Ms. And I'm going to drag this here so we know that we're talking specifically about our not our peanut M&Ms, our peanut butter M&Ms. Okay, so immediately when I look at this relationship between diameter and mass, I would hope my students see that there is what appears to be a linear association between these two variables, and it also appears to be positive, so that if our diameter is increasing, we expect that our mass is also increasing. Again, just to tie in some concepts that we've already talked about, I noticed that perhaps we have some outliers here that we may want to exclude from our data set. So if we wanted to exclude those and look at how that affects our association or our relationship, we could talk about that. Students in this example will have to answer questions on the relationship between these two variables. But really, we're looking at a linear model here. So we want to be able to not just decide if there is an association, because clearly there is one, but we also want to be able to model that association and come up with an equation in slope-intercept form that actually fits these data. So for the sake of time, I'm going to actually approximate this slope. So I have the benefit of knowing what it is. Let's say I get pretty close to approximating my slope. Okay. All right, so let's say I'm happy with this, although I would want my kids maybe to get a little bit closer. Another thing we can do is let's go ahead and compare that to our least squares line. So one really huge benefit in terms of linear modeling of our tool is that we have this least squares line here that will actually show us the best fit of these data when it comes to a linear model. And not only can we view this least squares line, we can actually look at the slope and the y-intercept of this in the context of our data set. We can also compare it to any function that our students make over here on their own, and have that conversation of those comparison between. And what I love about being able to do this and make these models in context of this real world data set is that once we've done that, first of all, now we can actually have these conversations about slope and y-intercept, but we can also predict what we think an M&M measuring 22 millimeters in diameter would weigh. So we get directly to those questions that we looked at previously from our state tests, and what the diameter of a M&M weighing 3 grams would be. So we're asking students to really take those concepts of like what we would have as our X variable versus our Y variable in context, and use those to make predictions about other M&Ms, and sort of like a universally understood topic of an M&M data set, which students are obviously very familiar with. All right, and our final topic, Algebra 1 topic that we're going to explore using real world data, is nonlinear functions and models. So in the context of Algebra 1, students will look at a couple different nonlinear models. They'll look at quadratic models, but I chose us to look at exponential functions. So our 2 associated Common Core standards for this, well, we have several others. You can look at the QR code there. The 2 that I pulled out are constructing linear and exponential functions, given a graph and a description of the relationship or 2 input-output pairs, and then interpret the parameters of a linear and exponential function. Obviously, we're going to look at exponential function in context. So really looking at this in the context of some kind of real world experience. And for this example, I pulled a lesson from Open Up Math, where students are asked to look at the net income of 2 different companies, and they're sort of given these baselines and then asked to graph an approximate model of what these 2 companies would look like if they make these kind of 2 future growth choices to increase their profits. So one's going to increase their net income by 0.5 million each year. So obviously that starts to look like a linear model if we're just increasing by the same amount. Or we have this other company that's going to increase by 15% each year. And so students graph these 2 in context and talk about the 2 different types of models that they come up with, one linear and one not. So if we want students to build on a lesson like this to explore this in more depth, we can give them a real world example that hopefully they can relate to. In this case, we're going to be looking at how ads for the Super Bowl have changed over time. And obviously, before we even get started, we can probably have a conversation with students about how Super Bowl ads have probably increased over time. Maybe they have increased by a constant rate, or maybe they have increased by a not constant rate, so potentially an exponential rate, which is what we're going to explore in these data. Before we start, I want to talk a little bit about where these data come from. So this data set contains information about the Super Bowl from 1967 to 2015. So definitely we would expect within that time that advertising has really drastically changed. So we may from the get-go be able to make a prediction that probably this is not going to be a linear model. So this is a little bit about our data. We're going to have 50 cases and 9 different attributes. All right, so I'm going to start by taking our Super Bowl number to the x-axis. So this is each of the Super Bowls in order. And what we're really interested in is how much a 30-second commercial costs. In this case, this is going to be in thousands of US dollars. So we can really easily see that we have this exponential graph here. And cool. Okay, so students can describe the shape of the graph and talk a little bit about the rate of change. Obviously, like we just said, probably not a constant rate of change, or we know it's not a constant rate of change. And then not only are students able to actually look at that in context and have a conversation about that, they can also begin to build their own functions to model this using an exponential model and manipulating our exponential model in context. Okay, so students can try out these different parameters until they find one that they are, until they feel represents this function. And finally, they're going to use all of this information that they've gathered from making their model, from looking at these data in context to be able to make a prediction about when a commercial is going to cost $1 billion. Just an insane amount of money to think about for a 30-second commercial. Okay, so students are exploring these in context. They're being able to describe different attributes of this graph. They're able to look at different parameters of this function in context. And they're doing all of this not removed from real world experience, but grounded in something that likely all of them have experienced over their lifetime of, watching television. Okay, so I wanted to, before we wrap up, leave you with this ability to explore some of these examples that we just looked at. I'm going to drop that into the chat so that you have it easily accessible. You can also type this into your browser or use this QR code, and I'll show you what it pulls up. So we have 4 different examples that we just looked at. If you already have an account with Tuba and you're using Tuba Premium, you can access any of these. If you don't and you just want to explore something on a basic account, you can look at our data story on linear modeling and try it out for yourself. We walked through some of the sort of steps of that data story together, but if you wanted to look at it in more depth and play around with it, you can access it using that link. Again, if you have a Tuba Premium account, then you can explore each of the different examples that we talked about together in more depth, try them out as a student, and hopefully see how they can be useful for implementing in your classroom in an upcoming unit or in a unit in a future school year. I also just want to share again with you, Michelle, is supposed to be a short link which you can copy into your browser. So you won't be able to click it directly from the Zoom chat. So again, I just want to offer support to you as you plan out the rest of your school year. If you are an algebra teacher and you're hoping to incorporate data into your upcoming lessons or your units, then I would suggest first exploring our content library. And then if you have any questions or you have any or you want any guidance on how to incorporate Tuba into your curriculum, please reach out to me. My email is colleen@tubalabs.com. I'm absolutely happy to support you with that process if you'd like to explore ways to incorporate this into your curriculum together. And before I leave you, I also want to show you a collection that we have in our content library. Well, first I want to show you a little bit about our content library in general, and then I'll show you our collection that's aligned to Algebra 1. So as I mentioned at the beginning of this webinar, we obviously are focusing specifically on Algebra 1 today, but data literacy and using data in your classroom is not something that's limited to Algebra 1 or even limited to math. So I want to show you that we have a full content library aligned to different grade levels. Within our math content library, we also have a full science content library where you can find lessons, activities, data stories aligned to different science topics and specifically to our NGSS PEs. And we also have a data set library where you can explore the different data sets that we have curated on our platform. And if you don't find an activity that meets your needs directly in the classroom, we also have a new activity feature where you can create your own activity, and that is forthcoming. And finally, I want to show you our collection that is specifically aligned to Algebra 1. So if you are using the illustrative math curriculum for Algebra 1, then you can look at this, what we call a collection, essentially just like a centralized place where we've put together a collection of resources that we believe align really well to different units of the illustrative math Algebra 1 curriculum. So these are the units that are covered in this curriculum or in this collection. It's obviously not every unit that gets covered in Algebra 1. So our goal is not necessarily to align to every single lesson or every standard, but just to provide some ways to enhance the different units of Algebra 1. So if you're using illustrative math, I think this is a really excellent resource that will hopefully help to shorten some of your time looking through our content library. If you are not using illustrative math, I would still suggest giving this a look. You are likely teaching linear, quadratic, and exponential modeling in your Algebra 1 curriculum. And you may also be teaching 1 and 2 variable statistics. So if you are, then these lessons that we have curated from our content library should still be very applicable to you. So I would highly recommend looking at them and exploring our data sets, even if you don't find something that is that directly applies. Our data sets might be helpful for you as you're developing a lesson or an idea of your own. Okay, I'm going to drop my email into the chat one more, so that you have it one more time. And I just, instead of copying that, I just copied the link. Oh goodness. Huzzah. Probably would have been faster to type that. If you have any questions about how to incorporate this into your curriculum, please let me know. Would love to hear from you. If you have any questions, I'll hang out for a few minutes. You're welcome to put those in the chat. If not, thank you so much for being with us this afternoon. We hope to see you at webinars in the future. We'll be having one more round of this webinar tomorrow afternoon at 4 p.m. Pacific time, 7 p.m. Eastern time. So thank you all so much for being here. Have a wonderful rest of your afternoon.